Hello, my name is DC Kuhns. I'm the Executive Director of the Delmarva Community WellNet Foundation. And we're here today because our EDEN project is about promoting the use of renewable resources and the use and recovery of renewable resources. The example that we're going to talk about today is the Wandendale Water Reclamation Facility that has recently been permitted in Sussex County on Camp Arrowhead Road. And we're here to talk to Jerry Esposito, the president of Tidewater, whose subsidiary, TESI, is building a facility that will serve 10,000 people when it's completed and provide reliable, continuous resource of water for the farmer to use on his feedstock crops. This facility has been in the development stage for a couple of years. What we want to do is ask Jerry to answer a couple of questions so that we can get our viewers more familiar with how the facility came about. How you doing, Jerry?
I'm fine.
Why don't you talk a little bit about how Tidewater came up with this idea? Because as maybe our viewers don't know, this is unique. You are a private utility, and it's unique for private utilities to do this kind of a project.
That's a really good question to start off with, DC. We wanted to, for the last 4 or 5 years, get into the business of wastewater, and it became easier when the law in Delaware changed in the mid-2000s. We started doing regional planning when we realized that the model that we used in the water business, where you have multiple water plants over time get interconnected by pipes, may not be the most efficient way of doing it. So instead of trying to build a series of individual small plants that are inefficient and then later interconnect them, we decided we'd flip it on its head and go with a regional approach, find the best possible soils, best possible site, build the plant, and then bring the raw wastewater to the plant with the best possible soils and site for disposal and reclamation.
Okay, so what are the advantages for the ratepayer with this kind of plant?
Well, cost is the big advantage. Like anything else, if you do something larger, usually you get an economy of scale. And in the regulated wastewater utility business, that's very critical because there are certain fixed costs, like the number of operators that have to visit a plant, regardless of the size. Those costs are fixed, so if you can spread those costs over a larger customer base, the costs per unit go down. So the cost advantage is very large. We also believe that having a facility that can be expanded and built in stages will keep the initial costs down and build as they go forward, so future users will pay as they go, as opposed to having existing customers pay for future infrastructure capacity that's not needed.
Okay. Now, as you know, this facility is going to use 2 methods of reclaiming the water, rapid infiltration beds and also spray irrigation. What are the advantages in the spray irrigation? What are the advantages for the host, the farmer?
The farm family that chose to sign a long-term lease with us, and by long-term I mean 50 years, decided to do this first and foremost to keep the farm in farming, as opposed to some of the neighbors who were selling it for homes. So one of the significant advantages to the farm and the farm community and to this farm was to keep it in ag land preservation without having the state pay for ag land preservation costs. So the direct beneficiary, the farmer and his family, were able to get a revenue stream that is somewhat predictable and will increase as we bring customers in. The actual irrigation that comes from the spray irrigation will help the farmer have to not put in his own well, pay for his own electricity to put the water onto the ground. It has nutrients in it, so he can reduce his fertilization costs. And because it's applied at agronomic rates, there will be minimal, if any, runoff from the farm field. So it's applied when it's needed, and we have plenty of capacity because we have a large field with great soils.
Of course, the public has all kinds of questions about how this gets done, and one of the big issues when you talk about sewage, and I know we try and use benign terms like water reclamation, but it is the conversion of treated effluent. What are the environmental benefits from the plant?
Well, first of all, the sewage treatment plant that we're going to build is state-of-the-art. You can't build one better. It's called a membrane bioreactor. It will take the raw wastewater and bring it down after treatment for lots of constituents. The two of concern in the inland bays area of Sussex County are nitrogen and phosphorus. We're going to bring them down not only to below the levels required by the state's pollution control strategy for the inland bays, but also to below drinking water standard. If you look at the science, and we've done all the studies necessary and then some, if you look at the studies, you'll see that when we're done, the effluent from the treatment plant, forget the disposal method. If it came right out of a treatment plant and didn't even have a disposal method, it would meet or exceed drinking water standards, not just environmental standards. So certainly the environmental benefits of having a regional plant as opposed to a lot of little individual plants, all of which could have problems depending on the operators and depending on the waste source. You have one plant, you can have one set of operations, you monitor them. They're like anything else, there's an economy of scale of regionalizing it. If there's ever any kind of electrical emergency, you have one plant. This particular plant will have 3 electrical feeds besides a generator. So all of those contingencies are taken care of, and the groundwater will actually be diluted from the water that we're putting in. Background levels in the inland bays have very high nitrogen levels, believe it or not, and that groundwater eventually becomes surface water, so we're also actually benefiting the surface waters of the inland bays.
So wait a minute now, you're saying that the reclaimed water from the plant after the treatment is going to have less nutrients in it than other bodies of water, so nearby Love Creek, and also the aquifer, which eventually gets into the inland bays.
Yes.
And so what you're going to be doing is to lower the levels of nutrients in those nearby bodies.
Yes. We've done studies to show that on that site, there are levels of nitrogen in the water, depending on where you look on the site and nearby, where the nitrogen levels just in the background groundwater from various sources is actually higher than the required drinking water standard today. So if we're successful and can put a lot of water back into the ground, it will actually dilute that so that it gets closer to the drinking water standard. Yes.
And what about the fact that this is a regional plant? There are many subdivisions around, some of which have septic systems. There's been a general concern in the state of Delaware as well as the county that some of these septic systems are not working. I think the number is something like 19,000 in the state. What do you guys provide there? What do you offer there as an alternative?
What will happen when we are up and running is that we'll have the capability to expand the plant as needed. We will work with the county, for example, because we're right near, if not contiguous to, county planning districts and sewer districts. As communities with failing septic systems go forward and they want service either by us or by the county, we have the capability and the capacity to take these septic systems that are, over the course of the next decade or so, going to be required to upgrade anyway. And the upgrade may be a sand mound system with some advanced treatment. Estimates are these systems can cost anywhere from $10,000 to $25,000 on an individual basis.
Right. And
when they're required to be replaced and upgraded, it's done all at once, not over time. The alternative to hooking to a regional wastewater facility might be a lot less expensive and certainly much more environmentally attractive.